Hey everyone, time for another challenge, a little homework. And as usual, the idea is that you don't have to find exactly the same solution I found, but the idea is to experiment around what different solutions you can find to solve this problem. And only then, if you spend a little bit of time, you can look at my solution, and maybe your solution is even better. It's just a good way of testing your knowledge. And what we want to generate here is a snow generator. Now, I know what we've already seen is something like points that we can scatter used with different tools on the areas that look upwards, so to say. But the challenge here is that you want to create something that has a three-dimensionality to it. So the snow actually has a certain thickness. So it doesn't have to look exactly like this, of course, but something in this direction. So try it yourself first, and then let's have a look at a couple of solutions. So for this problem, there are actually multiple solutions. So let's start with a simple rubber toy here. And of course, first of all, we need to find the area where we want our snow to be. And we actually know a couple of ways. The two, I think, most common that should come to mind are first a group, because one of the options of the group is keep by normals. And this allows you to define a certain direction and a certain angle that you can define. And you can only select the faces or the points actually where the normals look in this direction roughly. So let's start with the primitives first. Let's keep it as group 2. We're lazy. So I use a blast and it's not what I wanted. Of course, we want to work with groups and we want to invert this. So this is what's left. And this works. The only problem with this solution is that you have very hard edges because it's based on faces. If you change this to points in the group as well, the result is a little bit nicer, not perfect, but it's a bit more round. So I would personally prefer points over primitives here. Another option to do this is the mask by feature node, which we just saw in the last video. So this part was easy. And here you can use a mask, of course, that is already defined. With this, we can't see it, but we could visualize it. There it is. It's a bit hard to see because of the shader on the rubber toy. So let's save a bit of time by just blasting away what we don't want. And here the trick now is that we use the attribute mask to define what we want to keep. So if the mask is lower than, let's say, 0.1, then it should be deleted. And currently nothing happens. And that's because the attribute is created on the points. And whenever you work with attributes in the group for the blast, you have to define the group type. Otherwise, it's not sure what to do for some reason. So let's try point, and there we go. Now we basically have the same result as with the group. So there you have it. We already have two solutions for this. Now the trickier question is, what do we do now? Because sure, we can just scatter on this. We could have also used scatter directly with a mask as an input. This is what we saw in the last video. So as the density attribute, and let's turn off the relax iterations and let's increase maybe the density instead of the overall number. And then you can do something like this. Same here when you just scatter directly on the deleted areas. But the problem is, though, this is flat, right? So as an alternative, why not just extrude the whole thing? Who cares? We just want to make this thicker. Now, if you do this directly with a normal distance, this works. And maybe this is already what you want. There's nothing wrong with that. But sometimes you just want the snow to be not going to the sides, but only upwards. Then I would not use the distance, but just like you would do it in another 3D program, you just take whatever you extruded and move it upwards. And you can do this with a front transform that you have to activate. Now careful, your instinct might be to change Y, of course, and you're not wrong, but for some reason it moves to the side. Why the hell is it doing that? Because we're currently in the local space, so relative to the face itself. A bit annoying default again, but let's switch this to global, and now we can actually move it upwards, and this might be enough. I can't decide what I like more. I think actually the other one was also nice to thicken it up, because then we have a little bit of a different look. Now we still have the shader on it, unfortunately, so a quick fix would be to just attribute delete everything, because we really don't care. And now it's a bit, harsh on the edges. Different ways of solving this. You can just use an attribute blur, which is already set to position by default. And by dialing this up, you can see it really just blurs the position and you get rid of the harshness. Another option would be, though, what I usually would do is I just convert this, remember, into a VDB, to be more precise, into an SDF. And then when I define the voxel size correctly, maybe do something like that. Oh, something went wrong. I'm not sure. Oh, I know what happened. I forgot the number one rule when working with a poly extrude. This doesn't seem like it, but it's still open in the back. So whenever you use the poly extrude, remember, output back, otherwise it doesn't work. So our attribute blur should have shown this as well. So this is our attribute blur, not too bad, but what you can see is we lose a little bit of volume. The VDB from polygons to turn it into an SDF has the advantage that it tends to keep the shape. And if I convert it now back to the polygons, then I get this. And while you might say this is not super sexy, maybe we lower the voxel size to get more detail. What you can do now is change the ISO value to make it a little bit thicker or thinner. Well, it dies at some point, and that's because maybe our exterior band and interior band voxels aren't high enough. So in other words, there is not enough information outside. And here you can see why I like this approach. It gives a nice soft kind of, billowy kind of look. And by the way, we can always combine this again with an attribute blur to make it even softer afterwards. It's up to you, and then we kind of get the best of both worlds. So I like this result. So let's put this together with our original one. And there you have it. I would say problem solved. Maybe let's add a nice color. The viewport has some color correction going on. So just to make it look like snow for now, I make it glow. Oh, that's the wrong one. This one. It's of course not correct, but if you would shade this correctly, then you wouldn't have to do this. But for the viewport, it's a quick trick. And again, if you don't like the thickness, we go back into our VDB in our convert VDB, and we can change the ISO value, which basically defines what it takes as the surface, what number it takes as the surface, and this way we can change the thickness a little bit. But maybe, there are other ways of doing this. A peak would have worked as well, right? So if I would have set this to 0, maybe a peak is another solution to make it wider, if I'm careful, or thinner, because what a peak does is it moves the points in the direction of the normal. So if you don't know the VDB from polygons trick, with the ISO value, a normal peak will do as well. So yeah, those were a couple of ways of doing each step. So actually we already know many ways of doing this. But now I'll show you a little trick, and that is that the side effects labs, I'm not sure if it's still there when you watch it, but the side effects labs have a snow build up. So they build this for you in their own way. It's a little bit slow, unfortunately, so we're waiting for it to cook, but you can see it gives nice results. So they already had that idea, and everything is already built in, including color, which is nice, so that we can quickly make our snow brighter. And then it has, the direction and the number of snow points and all that. So what is that? Well, wait a minute. What does it mean? Number of snow points. What I wanted to show you is what they did. So we can just copy that. And since it's an asset, we can look inside, allow editing of contents. What you find here is that they, interesting enough, created just a grid with and scatter on it. Then they project it down for some reason. I'm not sure even why. And then interesting enough, they copy spheres on it. Oh, interesting. With, it seems like random point scale. And with their own node, they turn this into geometry. We could have used a VDB trick for this, and then they blur it again with an attribute blur, just like we did, and then gave it a color. So that's an interesting approach. So let's quickly do this ourselves in a more simple way. We take our toy, use mask by feature again, and scatter there. We understand this, and we could have just copied normal spheres to it. That's not a bad idea. You could totally do this, but there's actually another interesting node you can use for the next thing we want to do to soften this up. We can use VDB from particles. Now, just like you can turn geometry into an SDF, you can also turn multiple spheres into an SDF, and this is what this thing is doing. It copies onto those points, basically spheres, so to say, and turns them directly into an SDF. And if you convert this back to polygons, you get this, dotty sphere-like look, and this is why I wanted to show this workflow to you. It's the same idea as the side effects labs node does, but slightly different in the execution. So if I merge this with a toy and again give it some color, this is also a pretty interesting approach. So I think we saw a lot of solutions for this problem now, each a little bit different, each look a little bit different, and maybe you find even a better solution than this. So either way, I hope this is helpful. Thanks very much and see you later. Cheers.